Hi everyone, we're ME26, the Power Assisted Toilet Lift team. My name is Nick Toper.
My name is Michał Sibilski.
And I'm Jeremy Bronin.
We want to start off by introducing our project and providing the inspiration behind our sponsor, Tim Krupski's vision. The sick, elderly, and disabled can often struggle getting on and off the toilet. Both in senior care facilities and in personal households, there is considerable risk of falling. It's common to have a caretaker assist with the toileting process, but the repetitive strain of lifting patients can lead to their injury as well. Our sponsors LLC, NSH Solutions, is investing in an idea to create a device that mechanically lifts users on and off of a toilet. This is something that will fit over and around an existing toilet without modifications to the plumbing. Our senior design team was tasked with developing his idea further, keeping in mind the weight, cleanliness, adjustability, and simplicity of the lift. What we'd like to share in this presentation is a summary of the design results our team came up with, the progress we made on the electronic controls and prototype, and the business advancements that we are providing to our sponsor. A portion of our concept design is based off of a standard commode that we acquired with the help of our faculty advisor, Professor Shaky. From the very beginning, we were intending to construct a full-size prototype of the power-assisted toilet lift, so with that in mind, we decided to utilize the resources we had by reverse engineering the existing commode seat and creating a new base. Within the base, 2 linear actuators and 2 gas springs are internally housed in telescoping legs, providing a lifting force of 400 pounds. By programming the actuators to rise to different heights at different rates, the seat can be raised and tilt the user at an angle between 15 to 25 degrees, gently placing their weight back on their feet. Our sponsor worked very closely with us on all of the finite element analysis work. After examining the compressive stress in the legs, a closer look was taken into the distributed load of the seat. Using results from medical journals to match the load distribution, a realistic scenario could be simulated. Results from these tests ensured that the seat and the frame won't unnecessarily deflect during operation.
As the user sits on the assisted toilet lift, they will need to control the lifting, tilting, and lowering motion. The controls are based upon an Arduino and motor shield, which you can see to the right side of the screen, and control the motion of 2 linear actuators using 3 buttons, one for up, one for down, and one for a tilt of a maximum of 25 degrees. We also added a potentiometer for speed control, and these controls extend to the full-scale model's voltage and current specifications as well. We created 2 small-scale prototypes during this project. The first version allowed us to test the controls and expose any design flaws. We discovered that at about 10 degrees of tilt, the hinges locked up and the seat got stuck. This phenomenon is known as kinematic locking and occurs when there are not enough degrees of freedom in a system. In the second version of the mini prototype, we resolved the kinematic locking problem by updating the hinge design for the rear actuator. This proof of concept demonstrated the device's range of motion as described in our sponsor's patent application, and also verifies the design we used to achieve that motion.
Our sponsor Tim and I were accepted into the Accelerate Yukon program through the Connecticut Center for Entrepreneurship and Innovation to pursue the potential market viability of the power-assisted toilet lift. As a part of this program, we conducted 50 interviews with nurses, caretakers, and other key stakeholders. The research helped validate our product market fit and informed us of necessary design pivots. Through this program, we were able to create a business model to encompass the commercialized plan of our product. We determined our potential target market to be $50 million for the first 3 years of business. As a result of the Accelerate Yukon program, we received $3,000 in funding. This summer, Tim and I will be participating in the CCEI's Summer Fellowship Program and receiving $15,000 to continue our development. In summary, the goal of this project was to design, analyze, fabricate, and test the second generation of the power-assisted toilet lift. Although we were not able to construct the full-size lift given the COVID-19 circumstances, we were still able to create a comprehensive CAD model designed around existing patents, with 2 gas springs and 2 linear actuators. We analyzed our design with ANSYS, built a miniature prototype to demonstrate the motion, and strengthened the business case for this product. We are leaving the product in a great state for the next phase of development. With the parts ordered and the basic control system configured, we can ensure a seamless fabrication for our sponsor. Moving forward with the development of the assisted toilet lift, we recommend further research into the ratio of the actuator and gas spring force ratings and into the overall visual design of the base. With that, we thank you for your time and we wish everybody happy toileting times with plentiful toilet paper supplies.